This is the instructional video for both activities to be completed on 10/20. So first we're going to talk about the tides note catcher, and second we are going to talk about the gravity and tides worksheet. So let's talk about this one here, the tides note catcher, which is what we're going to be doing first today. So when you click on the tides note catcher assignment, this is what you see. As we watch the short video on tides, have this document open and fill in the chart based on the video. And right here, I included a link to the video in case you wanted to go back, rewatch, or you were absent. So let us click on and make a handout of the tides note catcher. So when you open up the document, you see these boxes. You see, does the sun or moon have greater gravitational influence on Earth's tide? So once you hear the answer or see the answer in the video, you'd click and type your answer. Second box, what is the force behind tides? Give you a hint, it's what we've been talking about all this week and half of last week. The next box, the moon's pull is blank on the part of the earth, blank, blank, the moon. And what else did you learn from this video? And we can see the phenomena of tides with the lighthouse where there's all this water and then there's no water, right? And that's a common occurrence that happens just about every single day. I wonder why, right? Now we see this picture here. We see something about the water and the moon. So that's what we learned in the video. Right, the next assignment that we're talking about in this video, because we're doing them on the same day, is the gravity and tides worksheet. So what we're going to be doing in class is work on reading the article about gravity, the moon, and tides. Okay? So the highlighted and bolded items are the important things. We're going to be summarizing it together in class. Then we are going to answer some questions. Why are the ocean tides so different everywhere? Right? As we have our sentence starter here, ocean tides are so different everywhere because, and this is where you would fill in your answer. So after we've read the article, answered the question as why tides are different, we're going to be exploring. And we're going to be launching 2 simulations. So the first one and the second one. So as you explore and do a little bit of manipulation and watching what happens, we're going to come down to our multiple choice questions. Okay. So to answer these multiple choice questions, you have to scroll all the way down and put your answers here, right? This multiple choice area, this is a picture. So when you click on it, it won't let you edit because it's a picture. So once you have your answer for number 1, you'll scroll all the way down and type your answer in next to number 1. Okay? And repeat for 2 through 5. So here we go. Number 1, what would happen to the ocean if there wasn't a moon orbiting the Earth? Choice A, the moonless Earth, would mean that the water of the ocean would be equally distributed around the Earth and we would have almost no tides at all. B, a moonless Earth would create the lowest tides. Or C, a moonless Earth would cause the sun to dry up the ocean, leaving no water on planet Earth. And then when we get to high tides and low tides here, we have a little text to read and a picture to see. It says, as the moon orbits our planet while the Earth is rotating around the sun, the part of the Earth that is facing the moon experiences a stronger gravitational pull, towards the moon from the Earth's center. And that's what we saw in our water balloon demo this morning. It's so strong that it causes the water in the ocean to bulge outwards towards the moon. The center gravity of the Earth is also pulled at the same time. This causes a bulge on the opposite side of the planet. The bulges also move along with the pull of the moon as it orbits the Earth. The areas of the Earth where the bulging of the ocean is occurring is experiencing high tides, right? More water. So question number 2, what type of tides are formed in the other areas where there is no bulge, where the water is pulled away from the Earth? A, low tides, B, no tides, or C, the ocean freezes? Number 3, why does the moon have a stronger influence on the Earth than the sun, causing tides? A, the moon is much closer to the Earth than the sun. B, the moon is larger than the sun. Or C, the moon is further away from the Earth than the sun. 4, identify the tides. A low tide is at what point on the land when the tide goes out? A, the lowest point. B, the lowest point halfway down the seashore, or C, the highest point? So a low tide is at what point on the land when the tide goes out? And number 5, in the picture on the left, the tide is out. Can you point out where the high tide line is during the high tide? So number 5 is a hint for number 4. This picture is low tide. So here's where you would put all of your answers. And we have a couple of fill in the blanks here. Number 6, why doesn't the Earth move in towards the sun? That is, why doesn't the Earth spiral into the sun? So you need to work on filling in the blanks here. The Earth doesn't what towards the sun because. Number 7, why is the moon more influential on the Earth's tide than the sun? So you're filling in the missing words here and provide your reasoning here. And the conclusion, what is the relationship between the gravitational pull of the moon and the cycle of the tides, which is the main point of today? This is the big question. How does gravity relate to the tides on Earth? So when you're done this assignment, this gravity and tides worksheet is graded, while the note catcher, the first one I showed you, is just collected. So make sure you're trying your best, as this is the last part of gravity that we're going to talk about.